Let's try something new. I'm going to go over the answer to the Will Page problem in the quiz here in this video. Let's see if this is a good way to get this across. This problem is particularly interesting because so many people had trouble with it and because I thought it was going to be really straightforward. Obviously I was wrong, and so there's something we need to get straight here. So in this problem, Will had collected measures about veterans, and he wound up with this graph with 278 no's, 227 yeses. It doesn't matter about the veterans. It doesn't even matter what no and yes mean. The question was, is it plausible that if it was really 50-50, that we would get a difference this large just by chance? Let's see what we do. And the thing to note is that this problem is identical to the Aunt Belinda problem. It just has different numbers. So these problems are called isomorphic, a fabulous word, but the point is they're structured exactly the same, except here we have 505 cases. In Aunt Belinda you had 20. Here there are 278 of the large ones, and in Aunt Belinda there were only 16. We can use exactly the same technique. So what did we do with Aunt Belinda? We created a collection with 20 coins in it and did a random pick to make heads or tails. So now what we're going to do is we're going to make a collection with some reses, some for result, and we're going to make how many of them? Well, here we have a total of 505. So let's do 505. I'm going to make new cases, 505 of them. So now I have 505 and they're blank. So I want to edit a formula to give it some randomness, to give it the contents. And it's going to be random pick of, and it doesn't matter what we call them. Might as well call them what Will did, call them no and yes. So now I have 505 no's and yeses that really are 50-50. And let's see what that looks like. If I put the results here on this graph, oh, actually, let's make it just like the other one. We'll put them like that. That's what they look like. If I do Clover Y, repeatedly you see it moving up and down. Sometimes it's more no's, sometimes it's more yeses. And we can see it doesn't often get up this high, but what we want to do is collect measures. So first we have to create a measure and say, what's the number that will tell us back in the original graph how big the difference is? Well, there are a number of different ones, but the one I'm going to pick is the number of no's minus the number of yeses. So I'm going to take my collection here, and I'm going to create a measure. And I'm going to call it diff, and I want the number of no's minus the number of yeses. So to get that, I do count of res equals no, and I put on the outside of the parentheses minus the count of res equals yes. So this count is a number of cases, not a sum or anything like that, minus this count. If I click this, in this particular case, I got negative 13. What's our test statistic? That's the number of no's here minus the number of yeses here, which is 51. So 278 minus 227 is 51. So next I'm going to collect measures because I want to get all the different values of this, 20 to 15, 9, minus 3, 41. That looks like a big difference, but it's not as big as it is over here. I'm going to collect measures from collection 1. And that'll make 5 cases. And so I'm going to take my own advice and make the graph. I don't have to use a table. I'll just put it like that. I'm also going to see where 51 is. I'll go ahead and plot a value at 51, which is our test statistic. Now I'm going to collect more measures. Let's do 995 more. 995 more, turn animation off, and go. Shazam. Let's watch this happen. Let's see, there we go. We can actually watch it still collecting. We do have some over 51. Not a lot of them, though. Wonder what's going on back there. Okay, now we're done here. And I can select these. I point up at the collection, and I look down at the bottom. And there are 13 right now that are selected. That is what I was expecting you to do on the quiz. Let's go just a little bit further to something that we're coming to shortly, and that is the difference was 51, but in fact If it were less than negative 51 on the other tail over here on this side, we would also be surprised. You just was surprised that they were not even. So I'm going to plot the other value. Of course, the whole thing is symmetrical, but let's go ahead and count these up as well. And when I go here, it says 24. So here, our empirical probability is 2.4%. Either the 13 or the 24 would have been suitable. 2.4% that the answer is as extreme as our test statistic. Okay? So under usual circumstances where we use 5% as our border, this situation is one in which we would reject the null hypothesis and say, whoa, something strange is actually going on. Okay, that's it.